Okay. One of the good-sized requirements on the ACT is having students solve equations with one variable in them. And that variable is usually, you guessed it, X. Okay. And I also want to take an opportunity to talk about freshmen, because I teach freshmen much of the day, and I see a lot of what they're good at, what they get, what they kind of get, and what they really don't get. So let's start off with what freshmen really do get. They understand adding and subtracting and multiplying and dividing. So just as an example, like if I had x minus 3 equals, I don't know, 6. Freshmen understand that if you want the x by itself, then you've got to undo this subtracted 3. Whoops. Um, so if you want to undo a subtracted 3, then what you do is you add 3 to each side. So these will negate each other, and you wind up with x equals 9. So freshmen get that no problem. Okay. Another thing that they get, they understand that if you had 45 plus x, and let's say that equals 12, another thing that they get is they understand pretty much that if you want x by itself here, you've got this 45, and even though there's not a positive sign written there, that 45 is positive. So if you want to get rid of that positive 45, you need to subtract 45 from each side. So those two will negate each other, and then you go 12 minus 45. So if I do it backwards, 45 minus 12 is 33. So it's negative 33. So x is negative 33. Okay. So freshmen pretty much they pretty much get that. So undoing subtracting is adding, and undoing adding is subtracting. Not a big deal so far. And they also get, if you have x over 4 equals, say, 10, they also understand that if you have a divided 4, a 4 on the bottom, they understand then that you need to multiply by 4. However, when we reach this point, I do kind of get into something that the freshmen only kind of get. Freshmen, and also some of them don't even get how to do basic operations with these things. So let me clean this up. So just imagine that I'm looking over a freshman's shoulder, and they've got this problem in front of them. And I say, well, how do you get rid of a divided 4? They understand that to get rid of division, you got to use multiplication. They get that, but I'll often see freshmen do this. They'll say, well, yeah, you got to multiply by 4. And I'll say, go ahead and do it. And they'll do this. They'll put a 4 right down here. Okay? And then they run into problems because they put the 4 underneath the line. I don't know why that's appearing right there. Okay, so they'll put the 4 down here. And what that means is 4 times 4. So what they really have is they actually have 16 if they do it that way. So somewhere along the lines, a lot of our freshmen have gotten into this habit that when you want to multiply by something on the bottom, you write it on the bottom. And that's just not the way that you need to do it. If we have our x over 4 equals 10, and you want to multiply this side by 4, what you need to do is you need to multiply this side by 4, which is the same thing as 4 over 1. Now, some people won't bother writing this over 1 part, and I wouldn't blame you if you didn't, but I try and tell my freshmen to do it because if they don't, they wind up with both 4's on the bottom, and then they get 16, and it messes them all up. So if you wanted to, you could put a parenthesis here just to remind yourself they're getting multiplied. So now what we have is we have a 4 on top and bottom, and that way they cancel out. But since we multiplied this side by 4 over 1, we're going to multiply this side by 4, or 4 over 1. If you want to put the 1 there, you can. Like I said, you don't really have to. But it's a good tip for beginners. So anyway, we wind up with x equaling 40. Okay? Okay, something else that freshmen get. They understand that if you have 15 x equals, let's say, 60, they understand that if you want to get the x by itself and you want to divide by that 15, so you do this, and then that cancels it out, and whatever you do to one side, you do to both, and that's reducible. Both of those numbers go into 15. You wind up with 4, so x equals 4. Freshmen get that pretty well. That's not a big deal for them. It's kind of fun talking about freshmen. There's none of them here, right? So why not? Okay, this next one I wrote twice, and I'm going to take two different approaches with it. And I want to talk about something called PEMDAS. It's a kind of a mnemonic for remembering the order of operations. P is parentheses, E is exponents, which I'm really not sure we're going to get to in this video. Multiplication and division are at the same level, and then last you do adding and subtracting. So as juniors, I would imagine you've heard PEMDAS probably enough. So let's look at this problem, and let's do it the hard way first. I'm going to notice that I've got this divided x here. So I've got x on the bottom. How do you get rid of a divided x? Well, you multiply by x. And no, we don't write it on the bottom, because then we get x squared, which is not what we want. We're going to multiply by x over 1. Okay, so even if you don't want to write the over 1 part, you could do that, but please remember to put this x up on top, so that way you remember that you've got x on bottom and top. So anyway, if we multiply this side by x, or x over 1, then these x's will cancel, and so we've got 6 over 1, so we've just got 6. But if we multiply this side by x, then we also need to multiply this side by x. And freshmen will often forget that you've got to multiply that by both of these. So x times 7 is 7x, and then x times negative 1 is negative x. So we wind up with this, 7x minus x, that's 6x, equals 6. And then we're back to just dividing. We want to get rid of that multiplied 6, so we divide by 6. 6 over 6, x is 1. Okay? Now, I think that was the hard way. Talking about PEMDAS, the order of operations here, multiplication and division does indeed come before addition and subtraction. But look at these. These are what we call like terms. And since they are like terms, they're both just numbers, that means that this really, you could look at it as 7 minus 1, but another way to look at it would be to say, well, it's not really 7 minus 1, it's actually just 6. Okay? So we kind of went against PEMDAS by doing our subtraction first, but since they were like terms, it was fair game. So now, let's look at this. If I was looking over a freshman's shoulder and they had this problem in front of them, whoops, what would I tell them to do? Well, if I think that they can handle it, if I think that they're ready, what I would do is I would say, okay, this side is a fraction, right? And they would say, yep. And I would say, is the other side a fraction? What was that? I can't remember even what that was. And I would say, is this side a fraction? And they would say no. And I'd say, but could you write it like this? Could you write 6 over 1? They'd say, yeah, it's still 6. So now what we have is we have an equality. One fraction equals another fraction. And a nifty trick that you can do when a fraction equals a fraction is you can do what's called cross multiplying. And so what you wind up with when you cross multiply is 6 times 1. See how that kind of looks like a bow tie? 6 times 1, and then you've got 6 times x. And so now it's essentially what we had back over here. Divide both sides by 6, and x equals 1. So there's different ways of going about getting these problems done, but as long as you get the right answer, I'm of the opinion that, hey, take whichever route works best for you. Okay, so what we'll do is we'll pause the video for a little while you guys tackle these problems and come up with your answers, and then when you're done, if there's time, you can watch the solutions. So here we go. Some of these we can breeze right through really quickly. I imagine you did. To undo this subtracted 1, what we're going to do is we're going to add 1 to each side. That cancels that out or negates it. And 2 plus 1, we wind up getting x equals 3. Okay, no biggie there. Here, this one, a little bit of a new flavor. What I want to do first, I think, is I want to get rid of this positive 4. To get rid of a positive 4, we're going to subtract 4 from each side, so that negates that. And so 9 minus 4. So what we wind up with is negative x equals 5. So the problem, even though I didn't really say it, maybe I did say it, I can't remember, but we wanted to get x by itself. We don't want the opposite of x. We don't want negative x. We want x. So the official way of saying this is multiplying both sides by multiplying by negative 1. Multiply by negative 1. But I think I just do it the cheap and fast way. I just go, okay, if I switch the sign on one side, then I switch the sign on the other side. If I just switch everybody's sign, the equation is still just as right. So x equals negative 5. Okay? Let's see here. We've got a positive 1/3. Those of you who are fraction phobic, you don't like rational numbers, 1/3, you could put it as 0.3 repeating if you were really desperate. You could do that. So I've got this positive 1/3. So I'm going to subtract 1/3 from each side. So that would get rid of that. And so 3 take away 1/3 is 1 2/3. So x is, I'm sorry, 2 2/3. So there you go. That's that one. If you actually did it the calculator way, what would you get? You'd get 2.6 repeating. Okay, so zooming right along here, 4x equals 18. Well, you've got x times by 4. Well, how do you get rid of a multiplied 4? You divide by 4. Dividing this side by 4, it goes away. Dividing this side by 4, let's see, 4 times 4 is 16. That leaves 2, so 4.5, or you could say 4.5. Okay, so that's this one, x equals 4.5 or 4.5. Next, even easier, I think. We've got this divided 4. Now remember, you need to multiply both sides by 4, but don't write it down here, because when you do that, you're putting it in the denominator, and that just messes you all up. So I'm going to stick with the beginner's way. I'm going to say we're multiplying by 4 over 1. So then, well, why does it do that? I have no idea. But the 4 cancels out, so we've got x equals, but if we multiplied this side by 4 over 1, we've also got to multiply this side by 4 over 1. And so 12 times 4 is 48 over 1. That's just 48. Okay, so half done. Number 6. Let's see here. What's it like? I guess it's a lot like number 5. This one, I think I'm going to take the route of this. I'm going to say, okay, this is a fraction. That's not a fraction. But what I want to do is I'm going to say, yeah, this is a fraction. It's 12 over 1. So that way I can do my little cross-multiplying trick here. I can go, let's see, 4 times 1 equals 12 times x. And now I just divide both sides by 12. And 4/12, that's reducible to 1/3. Or you could say x equals 0.3 repeating, or if you wanted to, you could say 1/3. Okay, so what's next here? Ooh, 7. This one's got x in 2 places. I've got an x there and an x there. So this is an x term, this is 1x, and this is an x term. It's half of x. Okay, so what I would like to do is I would like to get my x's all on one side, and then I'd like to get this 2 on one side. So that way I've got my x terms on one side and my my numbers on the other. So I think the way that I'm going to tackle this one is I'm going to subtract 2 from each side. So I've got 2 minus 2, so that's gone. So then I've got x equals x over 2 minus 2, because if I subtracted 2 from this side, I've got to subtract 2 from this side. So now I'm going to take and I'm going to get this x over 2 off of this side. So I'm going to subtract, if I've got half of an x that's positive, I'm going to subtract half of an x, or x over 2. So then that goes away, but whatever you do to one side, you got to do to both sides, sorry. So x minus a half of x, that is half of x, okay? And then one last little step, double both sides, because you want to get rid of that divided 2. So let's see here. If we multiply this side by 2, or 2 over 1, we wind up with just x. And if we multiply this side by 2, or 2 over 1, we get negative 4. That's your answer there. Okay, I'm going to make myself a little bit of room here because I seem to be writing too big. And I'm losing my voice. Good thing there's only 3 problems left. Okay, so this one a little bit different. My x is divided and it's on bottom. But I've also got this plus 3 thing here. And so to avoid fractions altogether, I'd like to multiply both sides by x plus 3. I can do that, or I mean, it's doing the same thing, just kind of written a different way. I can do my cross multiplying trick again. I can just say that this side is 7 over 1. So then I'll multiply those two and these two, and we'll see what happens. So if you did it a different way, you can still get the same answer. I mean, there's more than one way to do this. So 5 times 1 is 5. And then 7 times x plus 3. So 7 times x plus 3. Why did I stick in the parentheses? Because the 7 has to get multiplied by both of these things. So I've got 5 equals 7x plus 21. Why does it do that? Okay, so I want to get this 7 or this x by itself, so I need to get rid of this positive 21. So what I'm going to do is I'm going to subtract 21 from each side. That will negate that. And then whatever I do to one side, I've got to do to both. So 5 minus 21. Let's see, 20, 19, 18, 17, 16, 15. No, 19, 18, 17, 20, 19, 18, 17, 16. Okay, so negative 16 equals 7x. All right, almost done. I want to get rid of this multiplied 7, so I'm going to divide by 7. That's gone. But whatever I do to one side, I've got to do to both. So x winds up equaling negative, let's see, 7 times 2 is 14 with 2 left over. So negative 2 and 2/7. If you're a calculator person, maybe you'd rather see this. Let's see here. So we've got negative 16 divided by 7. Negative 2 point, we're going to call it negative 2.3. Blah. Negative 2.3. So these are the same. Okay, moving right along here. On this one, I'm going to get rid of this divided 6. So I'm going to multiply it both sides by 6. Remember, it's the same thing as 6 over 1. So that cancels out this 6, but whatever you do to one side, you got to do to both. So x minus 1 equals, and 11 times 6 is 66. I want to get rid of that minus 1, so I'm going to add 1 to each side. And so x equals 67. Okay, that one was pretty easy. Okay, this last one, number 10. I confess I had to throw one in that I thought was probably going to stump some kids. So what is this? You've got an x squared and an x. Are those like terms? Well, they kind of are, because x squared is just x times x. But this equation is what you would call a quadratic. Okay? It has 2 possible solutions. If you didn't get this problem right or it stumped you, you can forgive yourself. It was me messing with you. But let me show you what I would do to solve this. What I want to do is I want to get everything on one side. And that means getting this negative 6 out of here. So I'm going to add 6 to each side. And so I wind up with x squared plus 5x plus 6 equals 0. Okay? So looking at this now, what can I do? Well, there's a couple ways you can solve this. The first way is to excuse me, use factoring. And that means we're going to have an x term in each of these factors. And then we look at these signs here to tell us what's going on. Since both of them are positive, that means these are both going to be positive. And now we're looking for a number, a couple of numbers that will be factors of this and add up to that. Okay? So 2 things that go together to multiply together to make 6. So it's 2 factors of 6 that will add up to make 5. So 2 times 3 is 6, and 2 plus 3 is 5. So it's x plus 2 and x plus 3. So what does that mean? Well, this isn't actually our answer. it means that our answer is, or I shouldn't say our answers are any numbers that could make these things equal 0. So one possible answer here, x could be -2, and another possible answer here is -3. Okay, so those are our two possible answers for this equation. Sorry, I just couldn't resist messing with you. But if you figured it out, then pat yourself on the back, because everybody hates the quadratic. Another way to solve this would be to go, okay, this 5x, the 5 is called a coefficient. This 6 is just a number, and then this x squared has no number here, so that's kind of like having a coefficient of 1. So we've got coefficients of 1, 5, and 6. In the quadratic equation, you'll often see this coefficient written as a, this coefficient written as b, and this coefficient, or this number, written as c. So you go and you plug these into something called the quadratic equation, and I Googled it, and yeah, this kid had it tattooed on his neck. Yeah, but anyway, if you plug in those numbers for a, b, and c into this equation, you will, if you use the plus sign, if you use the plus sign, you get one of those answers, and if you use the minus side, you get the other one of our answers. But I think if you can factor it, that's the way to go. Anyway, there you go. Have a nice day.